In this problem, we have refrigerant 22 that undergoes a constant pressure process within a piston cylinder assembly from a saturated vapor at 4 bar to a temperature of 30 degrees. As per usual, we're going to neglect kinetic potential energy, and I want to find the work and the heat transfer of this process. So, as we know, the work of a process is the integral of P dV. And for us, the work is it occurs over a constant pressure process, meaning pressure comes out, and I'm just left with P equals V2 minus V1. To find the heat transfer, I'm going to use my first law, which is going to be delta U equals Q minus W. So again, once I find my work, I can use my first law to find Q as long as I know delta U. So what I need to find here is I need to find V1 and V2, U1 and U2, right? So I'm going to look this up in the table, right? So I'll start with V1 and U1, right? Which is at 4 bar saturated vapor. So this is for refrigerant 22, shown here. Okay. Again, I'm in table A8. This is refrigerant 22 based on pressures. So I scroll down to 4 bar, and I look in the saturated vapor, and I see that my volume is 0.0581, and I see that my energy is 222.24. So I'll go ahead and jot those down. So again, V1 is 0.0581, and again that's cubic meters per kilogram, and U1 equals 224.24, and that's kilojoules per kilogram. Okay, now looking up state 2, which is 4 bar 30 degrees Celsius. So now I'm going to go look up V2 and U2. Okay, so I was already at saturated vapor. Okay, well, I guess let's see where we were. We were at 4 bar, and you can see that my temperature at 4 bar was negative 0.6 for saturation. Now I'm clearly above that at 30, so I need to move over to the superheated region, right? So I go to the superheated tables. I need to go to the 4 bar table, which is right here, and I see at 30 degrees my volume is 0.06872, and my energy is 245.73. So I'll jot those two guys down there. So that's V2 equals 0.06872, same units as before, and U2 equals 245.73 kilojoules per kilogram. Now that I have this, I can calculate my work. So my work, again, is going to be my pressure, which is 4 bars. So I take it 4 times 10 to the 5th. Okay, get everything in its base units, times V2 minus V1, which is already in its base units. So it's 0.06872 minus 0.0581. And I can find the work then equals 4.248, and that's going to be in kilojoules per kilogram. Will be the units on that. Okay. Now that I have my work, I can use work and energy to find Q. So Q equals the change in energy. These are in kilojoules per kilogram. Work is in kilojoules per kilogram, so my units should work out here. So it's my final minus my initial, 245.73 minus 224.24 plus the work, because again negative comes over here, so plus 2.248 gives me a Q of 25.738 kilojoules per kilogram. So again, using what I know about work, using my first law equation along with the properties that I can look up in the table, given what I'm given here, I can easily find my work and my heat transfer using those equations and properties from the table.